Good morning, everyone. So my name is Ana Gutierrez, and I am the head of applications at Distran, Switzerland. I'm here today to show you our solution on how to speed up bagging processes by detecting vacuum leaks from a distance by using an ultrasound camera, which is a device like this one I have here. So today you will learn what an ultrasound camera does, and you will also learn how it can help the composite industry in making leak detection faster, easier, more reproducible, and also more efficient. And I will do so by demonstrating the capabilities of our ultrasound camera, by showing you real-life examples, and also showing you some testimonials from our existing clients. As you are probably very familiar with vacuum bagging. You know that leaks can appear in many different locations. Many times, especially at the beginning of the process, you have a lot of leaks that appear on the tacky tape when it's not properly sealed, or if you have like fibers that go through the tacky tape, and this creates some air intakes that later on can create defects on the final part. But additionally, you can have leaks on all vacuum fittings and all the vacuum connections that go to the vacuum pumps. And more challenging, sometimes you also have leaks in totally unexpected locations. So for example, you can have leaks because you have some punctures, some holes on the plastic bag, and these are really challenging to find, as we will discuss also more in detail later during the presentation. So, and as you can see, you can have leaks in many parts of the vacuum bag and the whole process, and you do so by, at the moment, using mostly human hearing and single microphones, so an ultrasonic detector with a headset. What happens is that, especially when you have big parts like wind blades, for example, or boat parts or aircraft parts, this becomes really tedious and is very much time-consuming. And on top of that, there is an additional drawback of these methods, which is that they are user-dependent. Of course, human hearing is user-dependent, but here I'm also talking especially about the single microphones, because using single microphones, it requires quite some experience and is not so straightforward to, in a production hall that is usually noisy, distinguish the sound from a leak from the background noise. So therefore, depending on the operator that does the inspections, he may be able to find 100% of the leaks that you have on the back or not. So on top of that, actually, sometimes you have very complex parts which you don't even have maybe access to. So for example, imagine if you have a cylindrical part, or if you have some like internal bags, you don't really have access to go with the single microphone or to go and hear for the leaks. So this represents an additional challenge. Therefore, this is a bit the introduction of my presentation. I hope we all agree that finding leaks is a challenging step in vacuum bagging. Is time critical. In the case of some of our clients, before using our camera, they were spending hours, or even in some cases, more than one day in making sure that the part was totally tight before continuing with the autoclave or with the infusion curing process. It requires also a lot of resources, involving many people looking for leaks in different parts of the bag, and especially with current methods that are tedious, time-consuming, and user-dependent. So for that, our solution is to use an ultrasound camera to pinpoint these vacuum leaks from a distance. An ultrasound camera is a handheld device, like you can see here, and it has a screen on the back where you can basically see in real time where the leaks are located. Many times, especially at the beginning of the process, we detect leaks on the tacky tape, so we can really speed up the first part of the leak inspection by detecting them with the camera. But I would say one of the main advantages is that we can also detect the leaks that are in the unexpected locations that I mentioned before. Why? Because now we don't really have, with the human hearing or with the single microphone, we don't have to scan the full bag, which in some cases can be hundreds of square meters, to look for defects or a puncture or whatever defect you have on the plastic bag. With the camera, you can see that from a distance, and it's immediate. Yeah, so now I'd like to show you how this works, this device works. So it detects, it pinpoints the leaks by detecting the ultrasounds that they emit. Of course, when the leaks are big enough, we can hear them. But especially when the leaks are small, leaks start by emitting ultrasounds and not sounds in the audible region that we can hear. And in addition to that, most of the production halls where you work are noisy. So in those cases, anyway, even if the leak emits some sounds in the acoustic, in the audible region, we are not able to listen to them. And this is why our camera detects the leaks in the ultrasound region, and we filter out all the other noises that are at other frequencies. And the way it works is that we have, in the front panel, we have an array of microphones. We have 124 microphones that are all displayed in this front panel. And so if there is a leak, the leak would emit an ultrasound wave, which will propagate over the air, and it will arrive to every microphone at a different time. And the camera, by analyzing the time differences, the times at which the sound wave arrives to every microphone, is able to reconstruct where these ultrasounds are coming from, so therefore where the leak is located. And on top of that, we have also an optical camera that is located in the center of the device to record the optical video image. So we overlay both informations from the acoustics and from the optical camera, and we can basically see leaks from a distance. And you know, when we started working in the composite industry, we also realized that actually for you, once you have detected a leak, you fix it. Usually maybe you put some tacky tape, and then the problem is over. But in many cases, we also saw that actually you put the tacky tape, but not in all cases the leak is actually fixed. So you can also use the camera to verify that after you put the tacky tape, there is no acoustic indication that, that is present. And here you see, because I've shown you some pictures, but here you see a video of how you would basically inspect and how you would see a leak. In this case, it's an aircraft part, and it's a leak that was detected from a distance of about 3 meters. And anyway, then later on, we went closer to verify where the leak was to later on fix it. Now going into more technical details of our ultrasound camera. So this ultrasound camera, which is called an Ultra CE, is a single-hand device which is 1.5 kilograms. It comes with a wrist strap, but also a neck strap to make the inspections more comfortable and also safer. And it can detect leaks from a distance, depending, of course, on the size of the leak that we have. So we can detect leaks from a distance of about 30 centimeters to several meters away. If the leak is big, you can see it from 50 meters away or even more than that. And we also, in this technology, it's an imaging technology, we talk about field of view, about the optical field of view and the acoustic field of view. But I'd like to show you what are the implications on that. Our optical field of view is 120 degrees. And what does this mean for you when you inspect your bags? This means that from a single point, with the camera, in most of the cases, you can see basically the full bag already. And you can detect several leaks simultaneously, like you can see in this example where we see a leak on a tacky tape and also a defect on a part, on the bag, sorry. But actually, on top of that, we have an acoustic field of view that is even better than that. So the microphones can actually listen to any ultrasounds that are within 180 degrees. So sometimes we have leaks that are not really in the line of sight for the optical field of view, but still are detected by the camera. And this can happen especially in big parts. And the way we display that is by showing an acoustic indication on the acoustic frame that you see for example, in the picture that we have in this slide on the right. So we have an acoustic indication, a red spot, and now I will show you what happens when I play the video. Basically, the camera is telling us, OK, move to the right because you have something there. And indeed, there were several leaks. So this acoustic field of view being 180 degrees basically reduces the, so we don't is meant to be there not to miss any leaks and also to guide the inspector during the leak inspection. During the inspection, you can take pictures, you can take videos, and you can also save them. And then you can export them by using either an SD card or by using Audalytics. Audalytics is our reporting tool, and is meant for later on, maybe if you are interested in generating digital reports. And as we know that the composite manufacturing is usually a continuous process, we also developed a protective wall-mounted box that can be placed in the production hall. You can lock it or not, but is meant to be there so that the camera is always accessible for any leak inspection that is necessary. And it also has inside 2 built-in battery chargers so that you ensure that the battery, that you always have basically a battery that is full and that several shifts can use the camera continuously. And this is maybe a little bit off topic, but I just want to mention that composites are one application of our camera. And we've been working in the composite industry for about 2.5, 3 years now. But actually, our expertise comes more from the oil and gas industry, chemistry, power generation, where our camera has been deployed already for more than 10 years and is used by industrial leaders, like some are mentioned in the slide, to detect leaks from actually any type of gas. So we detect hydrogen leaks, we can detect natural gas leaks, air leaks, ammonia leaks. The camera is gas agnostic. It means it can detect leaks from any type of gas, including, of course, vacuum. And it's actually thanks to one of our customers that is mentioned in this slide that we started investigating a bit more into the detection of vacuum leaks and vacuum leaks on composites. And it's thanks to a project that we had, a collaboration that we have with the NASA. So about 3.5 years ago, NASA started looking for the best available technology to find leaks, because they actually thought they had a leak they suspected they had a leak at the International Space Station. And they started, doing a lot of research and started testing a lot of technologies to basically send a device to the ISS for the astronauts to look for vacuum leaks, actually. And they tested our technology, they selected it, and since 3 years ago, they use the astronauts at the ISS use our camera to detect vacuum leaks up there in the space. And in the composites, we have clients, and we work a lot in the aerospace. We also work with some boat manufacturers as well, and with wind blade manufacturers. So especially when the parts are big, or you have also challenging parts where finding leaks is difficult, we can provide you a solution and we can help you. And I just want to mention 2 testimonials that we have from clients so that you see what is the impact of the camera use. So this is the testimonial from a wind blade manufacturer. And basically what they say is that leak detection on their backs, which are more than 100 square meters part, this required before the presence of up to 8 people and could take up to 2 shifts to ensure that the part was totally tight. And with the Distran camera, they could reduce this by having only 1 person going around the back for a very short period of time to ensure that all leaks were uncovered. And then this is a testimonial from a customer that we have in the aerospace, where basically they say something I mentioned already before, is that maybe in their case, they say that 80% of the leaks were usually easier, let's say, to find because they happen at typical locations, but the remaining 20% of the leaks were extremely time-consuming and often impossible to locate with traditional methods. And so those are usually the leaks that later on create defects on the parts and delay the production. And with the Ultra CE, they can pinpoint those leaks instantly. They say it's a game changer and that the results are immediate and reliable. So just to finish, I hope I could give you a good overview on the key advantages of using this technology. Being the first one, the fact that you can speed up this part of your process, especially when we compare with traditional single microphones, is way faster if you have an imaging technology. It's visual and it's easy, and honestly, it's really well taken also by the operators on site that have been struggling a lot looking or hearing these leaks. And it's a robust device, and so, as I said before, it's deployed in the oil and gas. It's used in power generation to detect leaks in gas turbines, in compressor rooms. So it's a well-tested technology and device. But one thing is to talk about the technology. What I would like is that if you are interested by it, I'd like to invite you to our booth. In our booth, we have 2 demo kits where you can simulate leaks yourselves, and you can detect them with a camera. And I think this will give you a better idea on how fast and easy it can be this leak detection. So don't hesitate to come to our booth. And otherwise, feel free to send us an email or check our website, which is distran.swiss. And yeah, I would be happy also to answer if you have any questions. Thanks for your attention. Yes. So
so you can detect both negative pressure and positive pressure, yeah?
Yes, this is true. Actually, what we detect are the ultrasound. So whenever there is an airflow, it doesn't matter if it comes from the higher pressure side to the lower pressure side or vice versa. This generates turbulences and ultrasounds, therefore, so we can detect positive and negative leaks. Yeah.
Also, is it necessary to have any specific training while buying this device? Do I have to get some training, or is it just simple instruction, which is like super simple?
It's a really good question. So as I said, it's a simple technology and is really meant to be used by any operator on site. However, since we understand that it's a new technology, we always offer a training with every camera that we sell. We offer a training so that we ensure that, at least everyone that will be using it understands that the camera detects ultrasounds and how it works, and also for us to share the best practices that we have learned over the last years.
And also, does it have to have some recalibration or anything like periodical? Because as I work in MRO, usually all the devices that we use supposed to be calibrated, and the calibration has to come with recalibration. Does it have to be sent to your facility, or how is it going?
Yeah, so unlike many analytical tools, the camera, so of course, is sent calibrated the first time, and then it doesn't require like really frequent calibration, actually. So we only recommend a maintenance to be done every 4 years. So yeah, this is a bit more simple, yeah.
Yes, we are using helium leak detectors for tightness of the vacuum equipment. Does this equipment can make the same effect? Because we are looking for a very, very small leaks to be found. So we are looking for the 10 to minus 3 millibar liter per second leaks. So can we detect this type of leaks also?
So they are vacuum leaks, huh? Again.
Yeah, vacuum.
Yes. So the limit of detection of the camera is about 0.2, 0.3 liters per hour. So in millibar liter per second or per hour, We can also discuss later to verify exactly if it would work. So it's not meant to detect leaks in ultra-high vacuum machines, of course, but for the numbers that you mentioned, maybe if it's in millibar liter per second, we can convert. It could actually help. Yeah, but we can discuss. I will be also in the meeting areas, and we can discuss more.
Hi.
Hello.
Is it just line of sight that it can pick up? And my example of that, we build big one-off custom molds for boats, and we often have issues on the mold side. So we're not going to be able to pick up any type of image from a leak on the underside of the mold, are we? We would have to get on the underside of the mold to detect the leak?
I'm not sure I understood exactly. So what your question is if we can detect also leak, like if you have problems on the mold itself? Okay. Yes, so we actually have two, and I think it's now 3 customers that have detected defects on some molds, actually. We don't have that much experience on that, I must say, but I have seen the way they detected them, and it was actually quite easy. Like they put basically the bag on top, so that because we always have to create this pressure difference, and then they went from below, from the mold side, and they could see. But I think it depends a lot on the type of defect that you have. If it's just some porosity and then it's not just one defect, I think it would be difficult. But at least in their case, it was easy. So I think it depends a lot on the defect that you have on the mold. Yeah.
Thank you.
Yeah, if there are no other questions, as I said, I will be in the meeting area, so don't hesitate to pass by and also, again, to visit our booth and see it by yourself.